Okay, good afternoon, ladies and gentlemen. Welcome to visiting lecture today with Western Caspian University, Azerbaijan. Welcome to the Honorable Mr. Javid Khalilov as a senior lecturer at Department of Programming. For the topic today is Introduction to Container Technology. Okay, and today's session is being live streamed on the Universitas STEKOM YouTube channel. And now I will read our agenda this afternoon. First, we will start class presentation by Mr. Javid Khalilov, continue with the Q&A session for all participants after finish of presentation, and continue with the document session for time of picture, and continue with the closing. So we will start for our class today, delivered by Mr. Javid Khalilov. The time is yours. Thank you.
Thank you very much. I'm glad to be here with you and give an amazing lecture about container technologies. First, I want to introduce myself. My name is Javid Khalilov. I work in IT industry for 12 years, and currently I am head solution architect at International Bank of Azerbaijan, and also lecturer at Western Caspian University as a part-time lecturer. But before, I have 5 year experience in Strasbourg University, so it's not my first session year, so don't worry. Our today lecture will be about container technologies, application virtualization, and the integration in modern CI/CD pipelines. So I think I can share my slides. Just a minute. So let's start from here. The slides is created by Brad Fisher, so I'm reusing his slides. Thank you for giving the access for his slides. We will talk about containers. So why containers are created? To answer this question, so first we should think why we come across to this path. Before containers and before virtual servers, even before everything, like 20 years ago, developers used bare metal servers. So bare metal servers are physical servers. So they're located in your room. You can see it, you can touch it, you can install it, you can unplug it even. And if you need to have some site, website, web system, database management system, you just log into this server and try to do something there. So it was not so efficient. Let's think why. Because there are some rules to have a server in your room. You should have at least two air conditions. You should have Faraday room. You should have server administration. You should pay a lot of electricity bills. So it's not efficient. And everything is just for having just one simple visit website, just 5 kilobytes of data, let's say that. So it was not good. Developers was not happy, and everyone thinking that we should do something to fix this up. And after that, virtual servers came. So it's not the virtual applications, but it's the virtual servers. So what system administrations think about? They take one physical server. They install some special software like VMware or VirtualBox, and they distribute the server to some small virtual servers. It's something like apple pie. You have a pie, but you cut it to the pieces, small pieces of pie. So we called it physical server virtualization. We take physical server, install some virtualization software, and start virtualization our server. Okay. For example, we have 32 gigabytes of RAM, six CPUs, and you distribute it to 4 parts. And you can use it like a small parts. It's very efficient. Why? Because your application will never use 32 gigabytes of RAM. So, but if you rent all server for the application, it's a waste of RAM or it's waste of resources, all resources. But when you distribute it to virtual servers, you can do it better. So you can install a lot of applications and you can do a lot of servers and deploy a lot of applications. The second part, you can have different applications, like one of them on MySQL, one of them on Oracle database. Another can be, for example, Node.js 16th version. Another application can be at Node.js 18th version. So there are, you can have applications on different version of the programming language, like exactly Node.js 16th version and 20th version. And you cannot install actually you can, but it's very hard to manage and hard to administrate different versions of one software application of different versions. But when you physically distribute server to the small virtual servers, it's much more easier to manage the servers. So it's like divide and conquer algorithm. So after that, some smart people think that we can sell these virtual servers through the internet. So because internet became faster, we have SSH technology. So we can just have SSH and rent some virtual server. We call it VPS, virtual private section servers. So everyone can now rent a server and have fun to play with it. To install something, even you as a class, you can rent a server and make some practice. But that's not the main point. After virtualization, people understand that, engineers understand that it's better to virtualize everything, not only servers, physical servers, but even application cores like CPUs, RAMs. Even they start selling virtualized database. We call it managed database. So it's how cloud technologies became popular. Now we have a different virtual servers, cloud technologies like AWS, like Amazon Azure, or a small one you can use, for example, DigitalOcean. So I want to start not from the slides, but from the practice. Okay, so what we will do now, we will rent a server from DigitalOcean. We will try to rent a server. After that, we will install Docker to the server. So Docker is one of the main container technologies. We will install their container technology Docker, and after that we will have some practice and theory together. Okay, so I'm trying to navigate to the Chrome. We have a lot of associated cloud technologies like AWS. It's the best one, I think. We have Azure. But for small things, we can use DigitalOcean. So I will go directly to DigitalOcean. So at the start, you can see this kind of admin panel here. And it offers you some real solutions, so ready solutions. Load balancer, managed database, DNS, droplets, even Kubernetes cluster. So it's why we use cloud technologies. It's easy, ready for use. I have already test project here. So you can see that I have no any resource here and everything is clear. In the create section, we can create Kubernetes cluster, functions ready, deploy ready functions. It's some kind of serverless, so Lambda, Amazon Lambda. We can make some database or storage, so whenever you want. The droplet is the analog of a virtual server in DigitalOcean. So it's some kind of marketing trick. Every company calls their virtual servers in different names. Like in DigitalOcean, it's droplets. In Amazon, it's EC2 instances. In Google Cloud, it's compute engine. But the main idea and the core is the same. So you will just rent a virtual server. I will go to droplet section, creating the droplet. So first, what we need to do is to choose a region of the server. So every cloud company have a different regions. with data centers. The theory said it's better to have a data center near your country, near your application users will be using. So that's why we are using Frankfurt. I'm using Frankfurt because it's nearest for me. It's near for Azerbaijan. But you can choose, for example, even Singapore is near you. So you can see that my data center name located here. It's Frankfurt 1. The second is choosing virtual servers operation system. So I think it's the only thing that you cannot change after creating a virtual server. So you should be very careful at choosing virtual server. But as default, I will choose Ubuntu. But if you want something else like Debian, CentOS, or even in Marketplace, you can find a lot of things like WordPress, cPanel, OpenVPN, everything you want. We will take operation system, choose a less stable version. We will use basic. So in this section, you have some options for your virtual server, like how you will pay, how much you will pay, and what's your parameters of your server. I will choose this one, just for example. We don't need any additional volume, but if you want to block storage, like with additional data, if you have a lot of data, you can add volume here. And of course, we need a password for our server. Our user will be root, default user will be root. And let's write some password and not to forget it here. Okay. So I can create a lot of copies the same server if I want to create a cluster. But in our case, we don't need it. We just call it node 1. If you can use like 3 copies, it will be node 2, not 3, but I think it's not necessary in our case. So it will be located in our test project, and I'm just putting create droplet. You can see that in few seconds, uh, our server will be ready. So we will get the IP address, the root user, and password that we used. So let's wait just for some seconds. Okay, while it's downloading, I will talk you how to install Docker to our system. So we have a wonderful site like, by the way, our server is ready, docker.com. So it's the main site of Docker. You can see it here. And it have some subdomains. And one of them is get.docker.com. So we will talk about the script later. Let's see here. You can see that our server is ready. We have IP address, and we can do with server whenever we want. So I want to log into our server. So the question is how to log into the server. Maybe you heard about the technology that's Microsoft Remote Connection. You just write the IP address of the Windows server and you can connect there. But in Ubuntu world, in Linux world, we don't have any graphic interfaces. So what I will do, I will copy the IP address, go to my terminal. So if you are using a Windows, you will have a lot of headaches because you will need to download Python. So I'm using Mac or Ubuntu. So there are a lot of commands to logging to the server. I will write SSH root at our IP address. So SSH will connect a secure channel to our server, and after execution of SSH command, I will log into my server in Frankfurt. So you can see that now I am in my local computer. It's my Mac, but I will enter. I will create a fingerprint, and I will write the password. Okay, it's done. So you can see that before I was in my local computer, but now currently I'm not on my computer. I'm on the computer of server. You can see nothing here. It's absolutely new server, absolutely new computer, and it's located in Frankfurt. So it's a white paper for our new technologies, for our new application. Now, if we want to install something here, we can use sudo apt and install something. It's a basic Ubuntu commands. But how to install Docker to the Linux? So very easy. You can see that we have getdocker.com, and it will have some bash file, that will install Docker automatically. So we don't need to do anything. The only thing that we will do, we have the commands here. You can see it's a command, so it's not part of the code. It's part of the instruction. First, we need to download the script. We will make this command execute in our server. So curl command in Ubuntu in Linux, check the URL, find the file, and download it to your local machine. So you can see that I make ls command. It means that list directory all files that in the current folder. I have only one folder called snap, but I will write this file command, and I will check it. Now you see that I have a file called install docker.shell file. This file is executable file, and after the execution, it will install the Docker to our computer. And as I said, Docker is a main tool for working with virtual containers. So let's run this file. You can see the instruction here, sudo sh install docker sh. We just put the file here, and I'm starting installment. Okay, let's installment goes, and we can talk about what we'll cover. So after the installation, we will check our Docker status using Docker version command. So Docker version is a basic, simplest command in Docker, and it will return the information of our Docker CLI. And it will be the first command like hello world in our Docker world. Next command is Docker info. It will also give a more information about our Docker engine, not only CLI, but also engine infrastructure. So it's the second command that we will use. Also, we should talk about how Docker commands are structured. So it's also important. So maybe you work with Git, and maybe you work with GitHub, GitLab, or maybe Bitbucket. So if you are familiar with these commands, you will be very happy because Docker take as a base this this technology, and change command to similar to Git. So before you make, like, for example, Git version, you will have Docker version. If you use Git push, you will do Docker push. If you do Git pull, you will do Docker pull. So it's very simple to use, and you will like it. So before 2015, Docker have a different style, like I show here in slide. You will write Docker, and you will write a command. It was an old style, but it was not efficient. And Docker from the 2015 go to the new version, like you will write Docker command, and after sub command of the you want, We'll talk about it and we'll show how it works. For example, if you want to work with containers, you will write container and you will write some swap command here. But we should talk about what's difference between containers and virtual machines. As I said, virtual machine is a thing where you have a physical server and you install some virtualization tool like Oracle, VirtualBox, and Virtual VM, and distributes a server. But you can see that in this command, I never used any virtualization tool. I just installed the Docker. By the way, it's ready. You can see that we have a ready virtual Docker here. I don't use any virtualization tool for Docker. So you should understand that containers aren't virtual machines. They have very different reasons to use. So in the virtual machine, you absolutely distribute server in two or more parts. So it have distributed CPUs, distributed, let's say that storage, RAM, CPU, and everything. But containers are processes. So it's just a process on your tasking manager. So if you even open task manager, you can see some processes listed there from the Docker. So Dockers are running inside your operation system. It's not another operation system. It's a process inside your system. So also we have two main terms here: images and containers. So Docker images and Docker containers. Our lecture is about container technologies, but we should also know what's the image. So I'm not sure if you're familiar with object-oriented programming or not, but in OOP we have two terms like classes. In OOP we use some class, and we have some instances or objects of this class. So what's the idea? You create a class, you write a pattern for your object, like I wrote a human class. It will have some attributes like name, surname, and I will have methods like run, sleep. It's our methods inside the class. It's a pattern for our object. And for example, I want to create an instance of human class. So it will be like Javid, new human, and it will be the object of our class. So it means that I can use one pattern of class and create a lot of objects of one class. And the same with images and containers. Image is an instruction what our container should look like. We will not cover image in this session, so we'll talk only about ready images and containers. So you can write your own image, you can write your own instructions and create your own containers. But you can use also another people container. As you see, we have here get.docker.com. But we have another amazing site. Like we go here, we write hub.docker.com. So I think everyone knows about GitHub, where you can find another people's repositories, another people code, and you can use it. The same idea is with Docker Hub. So people create their Docker containers and images and push to the Docker Hub, and you can use it. For example, if you want MySQL, you just search it. You can set we have official Docker image of MySQL. You can just pull it and use it as a service. So nothing configuration, no configuration, no any headache with config files, installation, just Docker pull MySQL and you can use it. So it's how another people's image work. And let's have some practice now. Let's go to our server. So I said that our first command will be Docker version. You can see that we have two versions, Docker server engine and Docker client. So client is a CLI that help you to container with Docker's engine. Docker engine is the core functions of Docker. And you can see that our version is 26, which is the latest version, and it's enough for our. And also Docker uses Go language under the hood, under the hood. So it's not really needed, but it's better to know. So if we write Docker info, we will get a very detailed information about our Docker. You can see a lot of information about containers running, stopped, paused. So we'll talk about the total memory, CPUs, CPU architecture, and even operating system. So Docker have access to everything you can see. That's why it should be operated only from sudo. Sorry. So here is a simple demo of how we can run a simple Docker container. So we will use Docker container run publish some ports and name of the image. Okay, we will talk about it detailed now. So we will talk about some another commands like Docker. I said that we have a new style like Docker command and subcommand. So we will write Docker. We want to work with containers. So as command we will write container. And as I want to list all of my containers, I will write ls like in Ubuntu system. Docker containers list. It will give me this type of table. But as you can see, it's empty because we don't have any containers currently. We just installed the Docker, but we don't have anything. The same thing is with image. I can write Docker. I will change the command and I will write list. You can see that another table returned, but it's also not actual because it's empty. And now let's make some demo and work with image and containers like a boss. So I have a server. I said that we have a server here. And our IP address 46.101.109.194. I copied it. I tried to go here and you can see that nothing here because how web works. You need to install some web server, for example, Apache or IIS or Tomcat from Java to handle web requests. And if your server don't have any web handler, it will not work. You cannot get any page here. So it means that we need to install some web server. The simplest web server is Nginx. Maybe you heard about it. It's Nginx. So its installation is not easy. You should install unzip files, make some ports available, and a lot of things to do in the old times. But we can use Docker and do it better. So actually, in this slide, we're also talking about Nginx installation container. But to have Nginx, we should download this from Docker Hub. We'll go here. We'll write Nginx. It's an official image, so Nginx officially published their thing here. We will copy it. So I'm again writing Docker images, and you can see that nothing here. Now I'm writing Docker pull Nginx, and it will start downloading these image files. So what happens when we write Docker image? Actually, the container is the same thing when you write and download it. What happens? If you try running container without having an image, first Docker look to the local cache. If you already have Nginx image, it will start writing it. But if you don't have, it will automatically find Nginx and download it. So it will do the same thing that we want here. if you write Docker container run, not Docker image. But I will do it manually to show you. So it will download the latest version automatically. And after that, we should run our container to have a web server easily. And you can use this command in the slide, but we have another version. So what we'll do here, we'll go here. Each image have a instruction here, supported versions, quick reference, what's engines, it's a marketing thing, don't do something. So how to use this image? Every Docker image has this instruction. So you are very happy to have this site. Okay, we will find exactly that we want. Let's see. So I think this command will do very good things for us. Again, I'm reminding that we don't have any web server in our site server. I'm going to the server again. We install the image, and if we make a Docker image list, so you can see that now our table is not empty. So we have engines as a repository, we have latest tag, we have image ID. It's a unique ID of each container and each image. So we will use it to delete or start something. Last update was it's right and created, but its last update was at 6 days ago, and its size is only 200 megabytes, let's say that. So, but I still have no any container here. You can see that I don't have any container because I have image, but no any container created for this. So I will copy the command. That's important for us. Just a minute. I have something here. Okay. So what we will do? Docker run means that we are trying to run some container using some engines image. We will do it like this because our, like here we are using the image name and our image name is engines. So we'll make Docker run and we'll pass some argument like name. So each container can have a name to easily refer it. You can make it like web server 1, web server 2, or in this example, some engines. So we will left it here like this to have more accurate. Detag means detach. So it will make understand Docker that we want this container to be run as a background. So we can write this and make something that we want in the server again. But if we will not run this D here, our terminal will be blocked and we are forced to wait for this, okay? So detach is very important if you want to make your container work as a background. So the P tag, it's a publish word. So actually many people think that it's a port, but actually it's publish. So P, what makes P? It will publish our port. So Docker are a little virtual system, okay? And in this system, we all know that Nginx default server port is 80. But we should open this port to the public server, to our world. And we are saying that find the 80 port in the Docker server and publish it to the 8080 port in our real world, okay? And of course, we are writing the Nginx. It's the name of our repository, as I said, our image. So we will write enter. So this ID is a container ID. It means that our execution are successful, and it means that we have successfully launched our run our container. But how to check it? Okay, again, Docker image ls. We have one image here. And if we want to check the container, not the image, we will use Docker container ls. And what you can see, we have now container ID. It's also not, it's not the image. Don't misunderstand it. So it's based on the image engines. It's last executed command inside the Docker. And it was created 31 seconds ago. It's updated. You can see 54 seconds now. Its status is up, so it's not crashed. It's very good. We have port like 80, forwarding to 8080. And it's a name that we give to our container. So you can name it whenever you want. You want to Javid, you can write anything you want. It doesn't make sense. So it means that we are running a server, we are running a container here now. And if you go here to our server, what will be if I make refresh button? Actually, nothing should happen. Let's say it's normal. Because as I said, default port here is, it's actually, I'm sorry, it's actually, default port here is 80. But it's 80 on the Docker port, and we said that we are forwarding our port to 8080. And you can see that, oh, actually it works, but the web page is blocked because the network policy of our bank. But I'm writing it to the chat. And if you want to check it from your computer, you can check it and you will see that we have a web page here there. If you don't have any security policy, you will see it. So it's a basic container things. In this slide, you can see the detailed explanation of the command. So Docker attributes like P, D, and this thing have two versions. You write two lines and the word fully. Or you want, or like you write one line and only the first article. Like we don't write Docker run publish, we write Docker P for to have more to have less words in our command. So also you can exactly implicitly write a version of the image that you want. For example, default we are using latest version, but if you want the version not 2 or not 3 or not latest, you want to have version, for example, 1.11, you can explicitly write it. You can find the versions in Docker site here. I'm sorry, like here. We have all versions of Docker and different distributives of engines. So mainly they are have difference between the operation system or the base of them. Alpine is the best one because it's very lightweighted, and if you want to have something light, you can use it. So we have three main commands that will help us to detect what's going on containers. We run the container, it's good, but it doesn't tell us what's happening there. To check this, you have three very useful commands. So Docker container top, Docker container inspect, and Docker container stats. So Docker container top process lists. So it's a process list. What's happening inside the Ubuntu process of the container. Docker container is inspect, returns the configuration details of the container, and Docker container stats will return the performance statistics. So how many RAM using, how many load, how many CPU load of our container have, okay? Another two very important commands, I will explain that. So Docker container run and Docker container execute. So this I and T means iteratively touch. So practice says what? When you have a running container, it's not enough. In 99% of the cases, you will need actually to go inside the container and run some commands inside the container, Docker container, not inside the virtual server, but exactly inside the container. So if you want to start new container, run new container, and automatically do something there, you will write Docker container run and IT. But if you already have existing container that working for months like exactly, you can make Docker container execute, it's some command, and that IT. And after that, you will write the Linux containers that you want to make, like bash or ls or sh, and you can do something inside your container. Okay. So that was the basics of containering with Docker system. Also, we have a Kubernetes is about orchestration of the containers, but I think we can cover it in another section. So that's the end of my small presentation about containers. And if you have any questions, I am happy to answer them. Can you hear me?
Yes.
Yeah. So if students have some questions, I am happy to answer them.
Okay. Yeah. For all participants, if you have any question for the speaker, please add them to the chat or you can raise your hand.
It
Yeah.
will be
We have
better.
first question.
We have first question where I can just a minute. Where is the question?
I already read in the room chat from Mr. Abdul.
I'm sorry, but I cannot see it. Ah, yeah, from Abdul. I'm a little confused about the difference between virtual machine and container. Okay, that's a good question. So, the main difference between containers and between virtual machines is that virtual machines is absolutely separates our physical machine into different parts. So, if you have 8 GB of RAM, it will distribute it, for example, 4 GB for machine 1 and 4 GB for machine 2. And that's all. So you can only remove the server if you want to restore it back. So it's strictly separated. Even file system are separated. But in containers, we do not separate the operation system. We don't separate RAM. We don't separate file system. We just create a virtual process inside the existing operation system. So our RAM will not be distributed inside the 4 GB and 4. It will still be 8, but some part of them will be used by the Docker process. And how we will use it in CI/CD process is also a good question. So a lot of companies base their CI/CD logic according that they will have Docker image, and they're just downing the container and starting the new version of application, new container. So they don't deploy code exactly to the server. They just deploy container and run them for in CI/CD applications. Next question. Yeah, what's the difference between Kubernetes and Docker? I will explain it, Kenan. So Docker is a tool for working with containers. You can create container, run container, stop container, I don't know, manage containers, but Kubernetes, it's an orchestration tool for containers, and Kubernetes is created to control a lot of containers with one command. For example, you want to create 20 copies of engines. So you will not run Docker run container 20 times. You will create a Kubernetes command deployment that will start 20 containers automatically, and you can stop them, restart them automatically with one command, but you will manage a lot of containers. That's the main difference. So Kubernetes is created to manage a set of containers. By the way, it's created by Google as an internal project. Okay, how containers facilitate application scalability compared to traditional approach? So we have two types of scaling, horizontal scaling and vertical scaling. So in traditional approach, we will use virtual scaling. So what does it mean? You have an application running as a server. Server RAM, I'm just saying RAM because it's very simple to understand. Your server RAM is 8 gigabytes. And you see that your load, application load, is too high. So it's 90%, 85%. It's a risky situation. In the vertical, well, let's say that in the vertical scaling, you will increase the size of the server. So you have 8 gigabytes of RAM, you will now have 12 gigabytes of RAM. If it's not enough, you will have 16 gigabytes of RAM. But in Docker world, we will use horizontal scaling, which means we are not increasing number of server resources of the server. We will create another copy of the container. So in the case, we'll create second copy of the container or third copy of the container to make load balancer between the application. That's the main idea of horizontal scaling. So next question. So, okay, microservices. I think containers is the reason why microservices born, because without them, I cannot imagine how we can handle this. So, how we use containers using microservices? Let's think about it. Because when we have a lot of small applications, we separate our application to some microservices. We should deploy them individually. Can I have some board here? Maybe you know. Okay, I will do like this. So if you want to deploy the application, microservices, you have two approaches. Let's think that you don't use any Docker, any Kubernetes, and you have, for example, I will say exact number. In International Bank of Azerbaijan, we have 800 microservices. 800, exactly. And if you want to deploy them, it means that you should deploy 800 applications each time. If you want to update them, you should update them individually, 800 things, if you want to update everything. If you want to migrate them, it means that you should manually migrate 800 applications to the server. But if you use Docker and Kubernetes in this case, you can write the automation command that will deploy 800 servers manually, automatically in 1 hour, not 1 day or 2 days. So it's speeding our things, okay? So we will make one command, two commands, and our 800 services will be online in a very short time.
Yeah. Okay, thank you. I think it's very clear answer from Professora, and I guess no one else asking again. Okay, yeah, before I close this event, for our participant, please open your camera. I will take a picture on the count of three. Okay, one, two, three. Okay, another one. One, two, three. Smile, thank you for your information. Finally, we come to the end of visiting lecture today. We would like to thank you for Mr. Javid for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future with Western Caspian University, Azerbaijan. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Thank you for Mr. Javid.
Thank you very much. It was nice to see you.
Yeah. Bye.